Hi, welcome to Improving's Lunch and Learn webinar series. My name is Mike Bruce. I'm a principal consultant here at Improving. Thank you for taking time today and spending a bit with me. I'm going to share my journey of DevOps and the transformation that it has made for my career and why I think you should use the 3 ways for awesome DevOps. Over the next hour, I will be introducing the 3 ways from the book, The Phoenix Project. On a personal note, I will be forever grateful to Gene Kim, Kevin Bear, and George Spafford for writing this book. I have taken some liberties and paraphrased some of the content. I am not at all claiming it as my own. The commentary and any errors, well, I'll take full responsibility. My journey starts with this guy. In 2013, I met a guy named Tim Dahl. That's him on the screen. Tim was the release manager of a company I had just started working at as the director of development. Tim and his team introduced me to release management and Team Foundation Server, the precursor to Azure DevOps. Over the years, the process of release management became something that would change how software development, testing, and deployment would work. This was well before DevOps. This worked well with other tools and built practices of automating release of software. These tools have fundamentally changed how software is delivered. As the software evolved, so too did my career direction, a direction that I couldn't have imagined back in 2013. Did you know that Amazon and Google deploy thousands of times per day? Facebook, Netflix, and Twitter deploy their code more than once per day. I find it interesting that small startups and small teams deploy whenever they want, whether every code change or once per week. So here's my question. What's preventing you from doing the same? This is what DevOps is about. By doing this over and delivering the value quicker, you need awesome DevOps. Awesome DevOps is much more than a build and release pipeline. It is about a culture, and that culture is built on trust. As we say at Improving, trust changes everything. You must trust the people, you must trust the processes, and you must trust the products that allow you to do this. The 3 ways from the Phoenix Project lay out a formula based on continuous. So let's get started.
Hi guys.
The first way, the principles of flow.
The first way, the principles of flow. On the continuous integration and continuous delivery model, we use the principles of flow. This delivery is value. So think of it this way. The code you write must have some value. However, that value is never realized until it is released into the wild and somewhere, someone gets to use it. If that code is never delivered, what's its worth? What's its value? For the person that writes to check, they want that value realized as quickly as possible. The person writing the code, they want to know their efforts are meaningful and valued. That's what happens when their code is deployed. Over the first few minutes, we're going to cover flow from left to right. When we think of flow, we think of how the work will progress from the left side to the right side. We do this with lines indicating time pointing to the right. As time moves on, so should our work. We'll see how smaller batch sizes benefit us and allow faster delivery. I'll introduce the theory of constraints and how they affect our flow. And another important thing is we're going to make sure we don't pass those defects downstream. When we complete work, what we want to do is make sure that that work is done, moves from development over to the right to done. On a Kanban, this can be sure we move from left to right through doing and finally done. And the code, we may define done as code that has been committed to the repo, unit tests that have been written, and meeting acceptance criteria, and build is successful. This is continuous integration. Continuous integration is the merging of code with already existing code. This builds the code and runs the unit tests. Having the code stored in Git or another repository is a must. Should we need to, we can branch off for new features, hot fixes, bugs, or rollback should we ever need to. Please don't. Continuous delivery is the deployment of that code. At any time, our code should be ready to be deployed. It doesn't mean it has to, only if we want to. This is what is meant by deployable code. To really think about what makes CI/CD so powerful, we should take a quick step back in history and think about how we used to deliver software. The traditional way of waterfall is also left to right. One major difference is that there are many, is what's called batch size. A batch size is the amount of work that is performed over a period of time. Suppose you're on a project using the waterfall methodology. This project has a development phase of, say, 6 months, a QA phase, maybe 2 months, and of course, deployment and bug fix phases, or a support phase. Could you imagine being on the QA team and having to test the entire completed project in 8 weeks? I can't. The first item, requirements, really. Who can think of every feature they want for a piece of software? How do you know that that final project or product is what you want? Many years ago, I worked on a project that defined everything up front. We delivered it exactly as asked. But at the end of the day, it wasn't what was needed. Add a feature, scope creep. Change a feature, scope creep. For the next version of that software, we used Agile Methodologies. And there was a huge difference. Sprints allowed for smaller batch sizes, bugs found earlier, the software deployed more often, releasing that value. Requirements could be added at any time. Priorities could be changed. Everyone, all of the stakeholders were happier, and no one considered extra features as scope creep. Let me demonstrate the effects of smaller batch sizes have on this. This starts with large batch sizes.
I'd rather have one of these.
The second way.
Hi guys.
Hello.
Hey, thanks for helping me out here. I really appreciate it.
Right, you're welcome.
Each of you have a job to do. Okay, you guys good for that? All right, so this could be really, really easy. We're gonna just take a bunch of dice and we're gonna slide them on over to Nicholas. There you go, Nicholas. No, don't start yet. What you're gonna do is you're gonna find the lowest number on every single one of those dice, and once you find it on all of the dice, you're gonna pass them off to your sister who's sitting right next to you. And then, Sophia, when you get the dice, you're gonna do the same thing to the next lowest number, and when you get them all done, you're gonna pass them to your brother. And Alex, when you're all done, you're gonna find the next number and you're gonna put them all to the center. But here's the thing, we have a 2-minute timer.
That is so hard. That is so hard.
That's right, it is gonna be hard. Are you ready to get going? So
Yes.
let me see these dice. Let me see these dice, Nicholas. Are we ready?
Yeah.
Okay, Sophia, you don't snatch the dice. No taking the dice. On your mark, get set, go. So we got the number one. We got 1 on it, and we'll just zoom on in here, and we can see that we're getting all these 1s for all the dice. We ran out of time, so why don't we try now with using the principles of flow. All the dice with the third highest number that is on the dice, and this represents the delivery value, and we haven't even finished the time. As you can see by this oversimplified example, smaller batch sizes are easier to manage. These smaller sizes allow for downstream activities such as QA and deployment activities to work near simultaneously and save a hell of a lot of time. I really had a lot of fun with this video. My kids, I thanked them an awful lot. They had fun, even though they kind of fought me with it sometimes. So what prevents continuous flow from happening? Constraints to that flow. This is anything that creates a bottleneck. To address this, we can look at Ellie Goldrat's The Goal and the theory of constraints. The theory of constraints state that identification of a constraint is the first step. In the Phoenix Project book, for example, the constraint to most of their problems was a guy named Brent. Brent was over capacity, overcommitted. Everyone went to Brent because he knew everything about everything. Even if a task was simple, that task couldn't get done because he was doing other things that didn't allow him time, the constraint to do any work. Do you have a Brent? The theory of constraints say we should determine how to exploit that constraint so that its maximum output can be achieved. In the case of Brent, it was making sure he wasn't distracted and could focus on his work. Second, all other processes should subordination to that constraint. In other words, the constraint should determine the flow of the work, its speed. It also makes any sense that improvements after that constraint is a total waste. Really, what good is it to improve downstream activities if the constraint doesn't allow for faster flow? Third and fourth, all effort should be to elevate the constraint and enhance the capacity of that constraint. That will allow for faster flow. And the fifth step, the last step, is to repeat that process, working out all the constraints you can and maximizing the flow. Of course, this practice isn't perfect, but it is a good way to address bottlenecks. Tim and I would work again together at a lighting company. He and I built the DevOps team from scratch. We designed the CI/CD process for teams that were building applications that controlled lighting. At first, there were all kinds of defects getting into production. Thankfully, this was small enough that it was somewhat manageable. In each light fixture, there are two small radios. These radios would receive or transmit information to other lights, as well as mobile devices that would store any data in the cloud. It's quite impressive. However, defects that got into prod were costly. The light fixtures are in the ceiling and have mental cases around them. You've seen them. To hook up a device that could flash the fixture, get the firmware put back on, took considerable time. To flash 12 lights, for example, could take hours to do, not to mention the configuration of those fixtures. We built a system that allowed for continuous testing of each piece as it was committed into a repo and built. There were multiple languages used for the fixtures, radios, the mobile apps, the web APIs, the storage, and even the test suites themselves. It didn't matter. We focused our efforts on the continuous testing of pieces looking for constraints and finding ways to enhance the capacity of those constraints. One thing we did was to increase the capacity of testing light fixtures. We went from having one fixture per quality engineer to having several hundred lights connected to test automation suites. This way, regression tests could run with thousands of different configurations. By shifting that testing as close to the development as possible and doing full regression testing allowed the teams to find defects much, much faster. Defects were not passed downstream. This was shifting left.
The second way, the principles of feedback.
For the principles of feedback, continuous, relevant, and timely evaluation, building off the principles of flow, as explained in the first way, is critical. But this feedback is why it's important. What is feedback and why is it important? Feedback is information you receive regarding some action, usually for corrective reasons. Waiting for feedback at times, something we don't enjoy receiving, especially if it's negative. However, the only way we can get better at continuous flow is by getting feedback. If you're doing Scrum, you should be getting feedback and providing feedback on a very regular basis. During daily stand-ups, you're providing feedback to the team on your status. What did I do yesterday? What am I doing today? What are my blockers? You're also getting that feedback from your team. More structured feedback happens at the end of every sprint retrospective. This is the time that the team huddles together to review what they could have done better as a team. What worked? What didn't work? What should we stop doing as a team? So what we want to do is prevent problems from happening. The retrospectives can help us to prevent problems and worse, preventing problems from repeating. If we have a short enough sprint, the feedback is timely and relevant. If our sprints, or with waterfall, are months long, that feedback becomes less relevant, almost irrelevant. Continuous and timely feedback allows for faster detection and recovery. What happens when it's non-existent? Well, let's have a look.
I'd rather have one of these cars we made together by hand. Your guys and my guys together. You know why? Because those cars stand for something. Those cars stand for something pretty great. I'm proud of those cars. I'm taking one. Gentlemen, I'm going home in my new car. I thought it handled great.
This example exaggerates the lack of feedback, but it demonstrates almost perfectly what can happen when software development, when feedback is non-existent nor timely. Without faster detection, catastrophic consequences are bound to happen. On a positive side, note Michael Keaton's character, Hunt Stevenson, does display a lot of trust in his team. Catastrophic consequences are not common, thankfully. But let's take a peek at a couple. In 2012, Knight Capital Group lost $440 million in 45 minutes. They didn't push their new trading software to one of 8 servers. This one server was buying stocks at high speed that should have never been bought. More recently, Equifax was hacked, and 147 million Americans' personal data was stolen, resulting in a $700 million in settlement and costs. According to USA Today, this breach was because Equifax security officials failed to install software updates. The ability for everyone or anyone in the software delivery supply chain to stop the line should be encouraged. This requires our leaders to empower the developers, testers, operations managers, and any other internal stakeholder to not feel pressured to push the code when they know it won't work. Adding an impediment or a blocker to our task board or Kanban board and having everyone that needs to jump on a problem early allows for quicker recovery, helps the team learn, and gets everyone back on track faster. Don't allow problems to pass downstream into another's workflow. Address it early. According to the Toyota way, stopping the process to build in quality. Toyota's second pillar of TPS involves a cord, later changed to buttons, hanging over each work center. If there's an issue, this cord, the and-on cord, stops production, the appropriate people scrum onto the problem, then production resumes. Feedback matters. In order to get timely, relevant feedback, it's important to look at the feedback we're getting. Let's start with the customer. Suppose you walk into a chain restaurant or the company cafe, order your meal, and on the way out, you encounter the happy or not device. You press the button. Why? Was the service or the food good or bad? Was it the right temperature? Did the server get our drinks right? While getting all happy faces great, who really doesn't like getting happy faces? What does it tell us about anything? When I worked with Tim, me and Tim would go and eat, and we would see these happy or not devices. Tim would push the happy button, and just because he pushed the happy button, I'd hit the sad button. If he hit the right middle, I'd hit the left middle. The context of the feedback being provided was not there. It's not relevant feedback. The context of why we push a certain button was lost. It would be better to have a paper comment cards and then ask about food quality, service, cleanliness, etc. Even if not timely, it would provide more context, allowing the folks to do something if they needed to improve. Rate this app and write a review also provide feedback. At least with write a review, there's an opportunity to state why you only gave 1 star. But is it timely? If I find a bug, one that is stopping me from using the app, do I really want to waste more time when there are alternatives that may work? How about you? Do you rate apps, or do you have an app that gets rated? This is how feedback loops work, or how is it that feedback loops work for you? Please add your comments to the Q&A about this, and Eric will read them off towards the end. I want your feedback. It is timely and relevant. Now, don't get me wrong. There are benefits to these types of feedback. For the happy or not, the general sentiment is provided to the restaurant, and if they all got happy faces, keep doing what they're doing. However, don't expect them to get better, though, if they get sad faces, as they don't know what they can do to get better at. The rate this app, on the other hand, hey, in my opinion, it's great for the customer. Personally, I rarely download an app or buy from Amazon if there are less than 4 stars. What if we shift left? With this image here on the top. In this case, we're using a Kanban board, as shown in the top, provides quick feedback for the stakeholders of the system. There's a test case for a user story represented as a test tube. and more importantly, an indicator that it failed. The test was run by QA, and they determined it didn't meet this acceptance criteria that was provided. This feedback is definitely relevant. It tells you when the defect was found. It also tells you which user story it was, and most likely it's pretty timely. Timely feedback is feedback that allows development teams to quickly identify and fix issues in today's delivery. Running unit tests during a build allows the team to address problems before it ever gets to QA team, shifting left even more. We do this by automating as much of the testing as possible. Continuous testing, running tests during every commit or pull request. By providing faster and more timely feedback, the developer can address the problem while they still remember what they did. A great example of not running tests was evident on October 1st, 2013. If you were one of 250,000 users that tried to get on healthcare.gov's website to register for health insurance, you could see failure everywhere. Did you know that on the first day of being live, only 6 people were able to enroll? Testing was non-existent across the entire system. There was no feedback, no understanding of where things weren't working. Catastrophic consequences indeed. So just to recap, in 45 minutes, Knight Capital Group lost $440 million. That's $10 million a minute. Equifax lost 147 million Americans' data and cost them $700 million in settlement costs. Only 6 people were able to enroll on healthcare.gov's website on the first day. Continuous feedback takes all kinds of forms, but most importantly, it is the speed in which we get that feedback. Once the software is out the door, the cost of fixing that issue skyrockets. We need to push our feedback left. We need to find those defects earlier. This way, we can decrease our cycle time, reduce wasted effort, and deliver value to our customers much faster.
The third way, the principles of continual learning and experimentation.
Wow. Let's go to the next slide here. The continuous integration and delivery make up the first way. By delivering value quicker to the customer, we unlock the value of our code. With the first way, we look at the principles of flow and how smaller batch sizes really help us. With the second way, we learn that continuous feedback, pushed to the left, can decrease our cycle time and find errors and bugs and other issues much sooner than if we wait. We can avoid catastrophic results. It's also good that feedback is related to what we're doing. It needs to be relevant. In the third way, it allows us to do continuous integration. It's the third way that allows us to do continuous integration and continuous delivery and continuous feedback. The principles of learning and experimentation of continuous learning and continuous experimentation are where the magic happens. And to me, it's one of the most, it is the most fun of the 3 ways. Most of us developers have experimented from the simple hello world program in some new language we want to learn with every version of C# or Python. There are new features we want to try out. We are experimenting. We've gone way past the simple hello world too. There are 4 points I want to highlight regarding the principles of learning and experimentation. 1, you must take risks and experiment to try new things. You have to watch out for the status quo and what's being done. 3, we have to help to build the culture that encourages innovation and risk-taking. And 4, trust those that you work with and those you work for. So, How many times do you think you're going to try something before you quit, before you feel like a failure? If you've ever used WD-40, you know how great this product is. I'm sure you've had sponsored ads in your news feeds on all the things you can do with WD-40. This stuff is amazing. It's called WD-40 because it took 40 tries to get the formula right. Water displacement, 40th attempt. Had 39 failures to get it right. Risk is just not about getting the formula right, though. Taking and experimenting is having a belief that what you're doing will eventually be right. It is having conviction for your work. Take this guy. Know who he is? Here's another clue. He failed 5,126 times before he was accessible. That's a lot of failure. He embraced this failure and continuously learned from each attempt. James Dyson made 5,100 prototypes of his vacuum before he got it right. He became the #1 vacuum cleaner in the UK. At that time, a lot of risks and willingness to try new things. He was convinced that what he was doing was right. It didn't matter what others thought. He continuously applied the principles of learning and experimentation. Now, I'm not saying that that we can write a piece of code 5,000 times or 39 times either before we're asked to deliver. That would be foolish. It does mean, however, that we must be willing to try new things and not be afraid of failure. Netflix open sourced code called Chaos Monkey. It's available on GitHub. You can search for it. This code will randomly terminate production server instances. They also have a other variety of monkeys. The Latency Monkey, it introduces artificial delays. Conformity Monkey finds instances of their servers that don't adhere to best practices. The Doctor Monkey, checking for unhealthy instances. Even a Janitor Monkey to make sure the cloud environment is free of clutter. PagerDuty, a company that deals with monitoring and alerting, also a DevOps tool, holds these weekly events and experimentations on their production systems. They call these weekly events Failure Friday. Before starting Failure Friday, teams get together and discuss what features they are going to trigger. They'll have production servers turned off, network switches fail, random yet controlled issues that the teams must fix. Both Netflix and PagerDuty run these events to find vulnerabilities in their systems so they can make them more resilient. The teams learn from what failed and how to prevent that failure from happening again. When me and Tim worked together, we set out to find ways to make developers' lives better. We looked for ways that would reduce friction. Not only did we build CI/CD pipelines, but we helped to define the processes around the software delivery supply chain. We didn't follow any rules at the time and broke away from the status quo. To break away from the status quo, we could do so many things as written about. Do 5 things as written about by Peter Stark on peterstark.com. 1, make innovation a priority. According to Mr. Stark, it is impossible to be innovative if all you do is think about the current problems. 2, focus your time, set goals for the next year's game-changing goals. 3, ask others for involvement. New ideas come from all over. No one person has every idea and is designated as innovator-in-chief. 4, create a sense of urgency, knowing that the world changes fast. Accept this fact, be a part of the change instead of the speed bump for others. It's much more fun being a part of something incredible. And 5, recognize and reward both the success and the failures. Remember, failure will most likely happen. This is where we can learn the most. Recognizing and rewarding the failures may seem odd. Of course, we would recognize the success, but the failures? Sure. If we can learn from them and react quickly to address them, as PagerDuty and Netflix do, with the Failure Friday and the Chaos Monkey, why not celebrate? To do this, though, requires a culture that does not seek to punish us when we make an error, but to help us grow and learn from the error. One time, I really goofed up. I was sitting at my desk, and the CIO came over to me. Kind of odd that the CIO would come over to my desk. At the time, I was a web developer, not very senior, so seeing the CIO was surprising to say the least. His question to me was, what did I just do? I had no idea. I asked what he meant. He said the website is down. All I was doing was reviewing log files on the QA system. Well, he said, the traffic is coming from your network port. What happened was this. I was downloading a lot of web logs from the QA server. The server was on the same network as our production server. And when I started downloading these log files, the web server traffic was sent to the lower priority SMB traffic. I suppose I could have gotten reprimanded for this, but I didn't. He asked that I stop immediately. Of course, no problem. The web traffic is definitely more important. The networking team changed how traffic was routed internally and also set the priority for traffic appropriately. This was a great way to learn, and I felt that they absolutely had that culture that allowed me to do that. The culture wasn't around shaming someone for something, but rather learning from issues as they come up and providing a safe environment for open discussion. So part of the third way is to create a culture where people have a voice in what happens. Encourage new ideas from those around you. You will be happy you did. The principles of learning and experimentation go much deeper than I am able to go today. If you go to our homepage, this is what you see. Trust does change everything. You have to have trust in those that work for you to do the right thing. It's interesting how companies spend lots of money hiring people only to make it more difficult to do things because they don't trust them. Employees need to trust their leaders and managers that they're going to do what they say they do. The trust between colleagues is also important. I want you to know that I will be accountable for my work, and I trust you will too. It is trust that allows us to do CI/CD and know the processes will deploy our code safely and securely to the correct environment. It is trust that allows people to feel safe when explaining why something isn't working without fear of ridicule or negative reaction. And it is trust that allows an organization to increase delivery of value to customers while reducing defects. As you can see, the principles of flow, feedback, learning, and experimentation are the three ways. But it really boils down to continuous delivery of value sooner with less errors. To get there, we need to automate as much as we can. That automation will require some experimentation and learning to find what works best. When code is deployed, we need the feedback as quickly as possible to see our automation, if our automation was successful. We do this by starting the DevOps process early, shifting left the time the deployments should start, getting the environments up and running. I understand this is much easier in green fields, but it can be done with legacy applications as well. Thanks again for joining us here at Improving. If you have any questions, please post them in the Q&A and Eric will read them off to me.
Thanks, Mike. We've gotten a few questions through the talk, so I'll go ahead and start reading those to you.
Thank you, Eric.
The first is, during a shift to DevOps, there is a level of risk as the team adjusts to the new way, kind of like pushing too many defects to production since QA is overloaded, or a bottleneck in the dev process. What are some good ways to mitigate the risk and prioritize those constraints?
Well, that's a very big question. So
yeah.
One, to kind of, let's just break it down to start off with the risk and everything. In my history, it is managing the risk in such a way that you don't try to solve every problem first, right? So if we take smaller problems, or we take a big problem, try to break it down into smaller problems, we can get that risk where it's not going to have as much of an impact. So if you have a constraint in QA, try to get more people that can help QA. If defects are getting pushed to prod, find out why they're getting pushed to prod, and you have to go back to that QA and you have to start asking, well, what's causing QA to allow defects to go through? You have to identify that, and then you have to try to figure out ways to fix those problems first. Again, one of the things that we talk about in the first way is really not allowing the defects to go forward in passing them on. It's basically if me and Eric are working on something and I have something and I hand it off to Eric, and then he has to mess with it because it's a defect, I didn't do what I needed to for him to make sure I didn't pass it on down. Now, it's absolutely possible I missed something and he found it for me, which is great. That's the whole point of QA, really, to kind of be our check, right? But I shouldn't have passed that down to him. I don't value the QA process as something like, hey, I'm just going to throw you this, you test and tell me if it's broken. That is handing off that problem. And then from QA to prod, the DevOps process, as we mentioned in the third way, is we have to have that ability to stop that process, or we have to be allowed to stop that. The process has to have trust in that process, so we don't push stuff into prod if we're not comfortable with it. I think that answers the question.
Yeah, no, I think so as well. The next question is a good tie into some of the other lunch and learns that we've been doing, but do you see DevOps and Scrum or Agile as an essential part of each other, or do you think a company should be doing one, then the other first? Oh, no.
So when Tim and I built out our DevOps environment when we worked together last, we built that DevOps and we decided, what we're going to do is we're going to make sure that everything is done in a Scrum fashion. So the two really kind of go hand in hand. There's a lot of similarities, especially with the flow, the process, the principles of flow. So if you have a work item, and this comes from lean manufacturing and the Toyota way, if you have a lot of things, so let's take software and work items. So that software is tied to a work item in some form or fashion, whether it's Azure DevOps or Jira or some other tool, that when I do this work item, I have a piece of code that's associated with that work item. And as it moves through the system, the Scrum of, hey, I did this yesterday, I'm doing this today, and I can say I did this code yesterday. And that code may not be done until all the unit tests have happened. So that those unit tests have to be executed during a CI/CD build. And then that code becomes shippable or deployable. So the two go hand in hand. You should not try to, I mean, you can, but I think you have to do them both together. Now, if you started a Scrum and you don't really have the processes or the technical team that can help you with the CI/CD, you can start with Scrum. It's an easy win. There's no upfront cost to Scrum, right? It's a matter of, okay, there is a little cost. Take a class with improving on Scrum, right? If you don't want to take a class, you can Google Scrum and you'll find 1,000 references of Scrum. You just won't become a certified Scrum Master or whatever, right? But you can start that Scrum process and then evolve into the tools. Absolutely.
Okay, great. Another question. What hurdles have you encountered when implementing these principles with legacy systems or in organizations that are resistant to the change? And how were you able to, were you able to overcome those hurdles?
Well, that's a fantastic question. Let's start with the hurdles and overcoming that first. So if you don't have, obviously a lot of things can start with grassroots efforts, right? And that's cool, right? So we've definitely started in other companies as grassroots efforts, and you have to get some buy-in from people that maybe have the access to what you need. So whether it's Team Foundation Server or Jira and other tools that can help you build and automate that, if you work with somebody that has that access to those tools, you can start doing that. So by doing that, you can prove out an awful lot on how it works, right? So if I can do it, and then I can demonstrate it to my manager and my my director or my VP, and they start seeing that value, that's really, I mean, once they start seeing that value, that we have lower defects for our project that we kind of did on the side with, using the Scrum and CI/CD and all that. Once they start seeing that, the lights start clicking on, oh, I'm getting better quality results. There is not a single manager I have ever met that is not happy with seeing better quality software written. As far as going back into like legacy systems, that is really hard. But again, a lot of older systems have maintenance cycles, right? So you already have it on maybe a whole bunch of old servers. Maybe those servers have to get decommissioned. Maybe it's an opportunity to start the CI/CD process for provisioning hardware in the cloud. Who knows? It's not for everybody, sure, but by having that ability to start with in that kind of a case, that helps you to start figuring out what you need to do for that. And the changes you do in the legacy system, you can start doing those in small sprints. Again, smaller buckets of work can show dramatic results when you deploy code. So if you have 100 bug fixes, don't try to fix all 100 things and then deploy. Fix one or two and deploy. Fix one or two and deploy. It's easier to test. It's easier to get them out there, and you start seeing that, and you start, as a developer, I loved when I start seeing my code in production sooner. So if you fix 100 bugs for an old legacy system, and then you have a deploy in 3, 4, 6 months, that's not going to be helpful. So try to do smaller sizes of work.
Okay, great. So got a couple questions that are similar, so I'll try to blend them together. But it really comes down to the DevOps team, or the idea of is there a DevOps team, or if not, are there changes to the roles and responsibilities of the existing team to be successful at DevOps? So especially if you're coming from a traditional waterfall or semi-agile model and moving into the DevOps world. So team structure for DevOps.
Team structures for DevOps. I was very fortunate when I built out a DevOps team. We ended up having 4 full-time DevOps engineers, plus taking on the QA team and wrapping that in there. So we had a pretty decent-sized team, and we were all responsible for different parts of it. So one of us might be responsible for building out CI/CD towards mobile devices because we understood how the app stores and iTunes worked, and we could get into those, and we knew how those build processes worked. Another one of us would be responsible for building out the processes for teams to use it. So you can't just install software and say, hey, here it is, go do it. You really have to have some structure that says, okay, here's this tool. This is how we commit our code. So I'm a fan of GitFlow. It's an easy model. There's other models, and I'm not saying GitFlow is the best. It's definitely not the worst. I've used, where you have centralized repositories, and those could be difficult and not as useful. And so, we start off with these sets of goals that we want to achieve when we start implementing DevOps. So the team members would all know what the other person's doing, but we would all focus on certain aspects to help build out the DevOps for the organization. If you have a large organization with hundreds of development teams or hundreds of developers in multiple teams. If you have a small team, maybe a handful of developers. Right now, I'm working with a company, and there's a dozen developers, give or take, and so it's just me. But working with the management, I'm able to get a lot done by focusing. He's focusing on the processes, where I'm focused on how to get the teams aligned to use the processes he's putting together, and then using CI/CD and demonstrating that. Now, do you have to switch? Do you have to have people that are developers doing it? So this is a mixed bag. I have had strong developers become DevOps engineers because there's a lot of automation that gets written. But I've also had people that have no experience in software development other than school or OJT type stuff, come in and take on DevOps because they have a really good aptitude for that type of thinking. It's a little different than software development thinking. There's a lot of customer-facing things you have to do as a DevOps engineer, and that it does a ton of evangelizing for DevOps. Just ask anybody improving about me and my evangelicalizing of DevOps.
Yeah, exactly. So the next question shifts from team to technology. A couple different questions around the actual CI/CD process. One is how to handle that when it's heavy with third-party package software, and kind of related, another one on legacy systems. So if you're looking at CI/CD, how do you look at using that, leveraging that when it's third-party packaged software or a legacy system?
Okay, so third-party software in that I have a piece of software I bought from ABC company. I wanted to install that on my systems. So you can still have, there may not be any builds, so the CI portion is probably not there. But there are ways to using continuous delivery through more scripting that could push that software. So for example, Chocolatey is a Windows software package manager type thing. Don't comment if I'm wrong. If you start using scripting, like PowerShell can definitely start to install stuff. There's companies like Chef who they have the ability to make sure your environments are a certain way, and that certain way, like it's basically state configuration of, I want my server to look like this, so make it look like this, which means install the software if I need to. So if I have a new package from a third-party vendor, I may put that into a Ruby script that Chef can understand. It says, hey, this server here needs to have this software installed in this configuration, and it doesn't. So let me go ahead and make sure. Then there's also, of course, for Linux systems, if you're able to take a packaged software and put it into a container, you can containerize it. So Chef also has things that can do that for you. But there's a lot of these technologies that can help deal with legacy software or third-party software. As far as legacy software, the same thing, right? So if you've written it and it's just legacy, it goes back to what we spoke about earlier. We can, if it's like an EXE, again, we can script out how to deploy that using PowerShell or Bash or Python or any number of tools that can install it in its proper location. This is not a 100% true statement, but it's close enough. Anything that you can install can almost be automated. And if you can automate it, that means you've written a script to do it. And if you can write a script to do it, then you could put that script into a CI/CD pipeline. And if you can put that into a CI/CD pipeline or a CD pipeline, then you have started the implementation of DevOps. Now, it is always easier said than done. I've been on it where it takes tons of time to get stuff automated, to find out we're going to automate it one time, and it was like, well, why did I do that? But it's well worth that journey.
Great. We're getting close to time, but there's a few more questions, so maybe we can knock these out. But here's one that I know is near and dear to your current project. How can we do DevOps in an analytics solution?
In a what?
Analytics.
Oh, analytics. Okay. So, analytics. Are you talking analytics from the like an analytics platform, or are you talking analytics on the DevOps, the data for the DevOps?
Analytics project, I think, like a BI project.
Yeah, sure. So there are with analytics, the data, having CI/CD for data. So there's a couple things that I've worked on in the past. One is with SQL Server specifically, you can do backpack, DACpack projects. You can do the database projects in Visual Studio. Those you can CI/CD to go build your infrastructure or change it. So you would have basically configuration as code, or desired state configuration with your database. So with a database project, the desired state configuration will make sure your database is always in a certain thing. Data coming into the system, much more difficult, obviously, but the reports and the building of the cubes can certainly be automated. And there are several tools that you can use, like in Azure DevOps, you can do it. But you can also, again, it comes back to, can you script it? If you can script it, then you can put that into a CI/CD process. And that holds true for data projects as well, as several of our colleagues at Improving have demonstrated and done.
Perfect, thanks. And I know there's a few more questions. We probably won't have time to get to everyone, but please do reach out to us if you have a question that data can answer. But here's one I think that's a good one to close us out. If you had to start somewhere to prove out the value of DevOps or the CI/CD, where do you get the biggest bang for the buck? Is it continuous delivery? Is it something else? As the people are thinking, how they get the most value out of starting this journey?
Well, look, the journey for DevOps is a continuous learning journey, right? And the way that I like to start off is find something that is not going to knock you down and beat you up at first. You want to understand how the technology can benefit you and deliver the value. So find a low-hanging piece of fruit, pick it and eat it. So what you could do is find that small web app that you want to deploy and figure out how to deploy that out to AWS or Azure or Google Web Cloud or Google Cloud Provider platform, and test it. And then evolve on it, experiment with it. That is the third way, right? Is the principles of learning and experimentation. Find something that's not going to be overly complicated and start with that. That's a great way to get into DevOps. And then find somebody like Improving that can help you and guide you through the rest of that journey.
Okay, great. I think, like I said, if there's anything else, please reach out to us. There's several ways to do so, but Mike, thank you.
Thank you very much. Thank you, everyone, for taking time today. Have a good day.
All right. Thanks, everybody.